Hello everyone, my name is Amir Syed. Today we are going to discuss about memory management in operating systems. So, memory refers to storage needed by the kernel, the other components of the operating system and the user programs. In a multiprocessing or multi-user system, the structure of the memory is quite complex. Efficient memory management is very critical for good performance of the entire system. In this discussion, we will study more memory management policies, techniques, and their implementations. So, the topics are memory management requirements, memory management techniques, related issues, virtual memory, and so on. Memory management requirements relocation, branch addresses and data references within a program memory space have to be translated into references in the memory range of a program is loaded into. Protection, each process should be protected against unwanted interference by other processes, whether accidental or intentional. Fortunately, mechanisms that support relocation also form the base for satisfying production requirements. Next, sharing allows several processes to access the same portion of main memory, very common in many applications. Example, many server thread executing the same service routine. Logical organization allows separate compilation and a runtime resolution of references to provide different access privileges to allow sharing. Example, segmentation requirements, physical organization, overhead. Fixed partitioning, main memory statistically divided into fixed size partition should be equal size or unequal size, simple to implement, inefficient use of memory and results in internal fragmentation, and dynamic partitioning, simple paging. Memory management techniques, simple segmentation to accommodate dynamically growing partitions. Compiler tables, for example, no fragmentation but needs compaction. Virtual memory with paging, same as simple paging, but the pages currently needed are in the main memory, known as demand paging. Virtual memory with segmentation, same as simple segmentation, but only those segments needed are in the main memory. Segmented paged virtual memory, basic memory operations, relocation. These are logical addresses. Relative addresses are examples of this. These are addresses which are expressed with a reference to some known point, usually the beginning of the program. Physical addresses are absolute addresses in the memory. Relative addressing or position independence helps easy relocation of programs. A process in the memory includes instructions plus data. Instruction contain memory references, addresses of data items, addresses of instructions. Basic memory operations, linking and loading. The function of a linker is to take as input a collection of object modules and produce a load module that consists of an integrated set of program and data modules to be passed to the loader. It also resolves all the external symbolic references in the load module. The nature of the address linkage will depend on the types of load module created and the time of linkage, static, load time dynamic linking, runtime dynamic linking. Dynamic linking, referring the linkage of external references until load module is created. Load module contains unresolved references to other programs. Coming to virtual memory consider a typical large application. There are many components that are mutually exclusive. Example, a unique function selected dependent on user choice. Error routines and exception handlers are very rarely used. Most programs exhibit a slow changing locality of reference. There are two types of locality, spatial and temporal, space and time. Here we can see the representation of space and time. The first one is CPU. The second block contains the cache memory. After the cache memory, the next one is main memory. After the main memory, there comes secondary storage. You can see the CPU has more computational power. Next one is cache. The cache uh, takes the data from the CPU and sends it to the user very fastly. Main memory is a little bit slower than cache, and secondary storage is more slower than main memory. The first line is storage capacity. You can see the second one as access time, third one as cost and byte,